Hey guys, welcome back. Okay, a couple of things I want to do here before we really get started on the next thing. What we're going to do in this episode is work on the hash class to get the string of the memory pool, which you remember, let's see, if I look it up, I think it's under WinBase. We sent this string, new pool, and what we want to do is change that into a hash so that we can store that as I think we're going to store it as an unsigned integer. We need to store that so that we can find the pool again in order to delete it. And this is really the reason we haven't been able to test, because if I run this right now, we won't be able to find that pool and we'll memory leak, right? So, but before we get into that, there's a couple of things I noticed during the last edit that I wanted to fix. I wanted to clean up a couple of things. First of all, let me throw a new filter in here because this is getting to be a little bit crazy. Hang on a second. Let's see, add, there we go, filter. Let's add that's not where I wanted it, but okay. Let's add a new filter, memory management, something like that. And I don't want it under base. I want it under the game engine, which is where I told it to be. Why are you not coming out? Is it under? Oh, it is under. Okay, never mind. All right, let's put all these memory things into memory manager, just to clean that up a little bit. Okay, let's see. Yeah, a couple things I wanted to clean up here that I noticed when I was doing the edit. Now, let's see. Of course, I'm going to lose track of what I wanted to do here. Oh yes, right here. So this is kind of a holdover from when we were going to originally store aligned in the malloc part of the memory, which we're not doing anymore. We made this a pointer to a pointer so we could do the pointer arithmetic to do that. We don't need to do that anymore. Let's take that out. So let's do that. And that should be better. Okay, let me just double check. Yeah, this too. Let's take that out. Don't need that anymore. Okay, that should be fine. That's the way I want that to be. Okay. Gosh, there was some other stuff too. Now I can't remember what it was. Let me look at my scrap code here for a second, guys. Oh yeah. One thing I haven't really been doing like I should have been is using a namespace for some of these new routines. So let's go ahead and do that here. Now I realize there's nothing much in this class right now, but that's all right. Like such. We really should try to keep these inside of a namespace just to keep from any clashes with any, I don't know, anything else we might be doing or any other libraries we might be using. Not that we're really going to be using much in the way of libraries, but it's a good idea to do this kind of thing. Okay, so let's see. We got the memory block class. We do memory manager, memory pool does not. Okay, let's fix that one as well. I should say, guys, it is not easy to do these recordings and really think about the code when I'm doing it. I find I'm making mistakes that are really kind of stupid. That's the kindest way I can put it. But that's because I'm trying to actually focus on explaining stuff and keeping the video going. And I'm not as much thinking about the code as I otherwise would be. My full attention is not on it. Usually when I do something dumb, I'll realize it during the editing phase when I'm editing the video, and so I'll come back and fix stuff. So bear with me when I make a mistake. It will happen from time to time. Stuff like that really should not have gotten into the code without this namespace deal. So let's see, we should get errors. So yeah, just bear with me with that kind of stuff. It's going to happen. Let me grab this. So we're going to be doing this. care of that. There's a couple of other things I wanted to clean up too. Let's see, the memory pool class, right? Yes. Okay, that should compile, I think. Yeah, okay. All right, very good. Where do we want to go from here? Do I want to... I guess that's good for now. Let's put in our hash class. I'll come back and clean up a few other things in a minute, because I think there was a mistake I made back in the memory manager class down in here, the aligned malloc routine, but it'll be easier to explain. Well, no, I guess we could fix it now. Let's fix it now, and then everything will work fine. And then we'll go on to the new stuff. Okay, guys, let's take a look at the add new pull routine for just a second, because I made a bit of a mistake in here. So we want to go back and fix this. So the original pull pointer, which is what we want the avoid star to original pull pointer, because that's what the malloc ultimately is going to give us, this avoid pointer to avoid. And what we're doing right here is we're sending a reference to the original pull pointer, and that's fine. That's what we want to do, because we want original pull pointer to change, so you got to send a reference when you send this over. So what we're doing here is okay. This is good. However, what we're doing down in aligned malloc is not going to work. So you'll see I pulled in a pointer to avoid to original. Well, that's not what we're passing, guys. What we're passing really is, this is a reference, right, to a pointer to avoid. So this is really a pointer to the pointer, is what that is. So if I just throw this in as a void star, the compiler will accept it, because void star is kind of inherently unsafe, and it kind of inherently will convert that for us. But what'll happen is, this is the original value, so it'll change it down in here, like this will change in here, but when you return, it'll drop back to what it was, because if you guys know, you should know, C++ doesn't allow side effects. So if you want this to change, what you really want here is a pointer to the original, and then you want the pointer to original to be malloced. And I think in here we need to do this one right here, like such. Okay, that's what the routine should do. Then we got to fix this right here, pointer to original, and that should hopefully work. I know we keep changing this routine, but I'm hoping that'll do it. Maybe we can test it this time around. Okay. Good enough. I think that should be all right. Let's see, memory block class doesn't really have anything in it. I don't need this. We can take out the misaligned. We don't need that anymore. Get rid of that. I think everything else should be okay for right now. Okay. All right. Now let's talk about the hash class. This may end up being a somewhat short episode, because I'm not really going to explain the hash class all that much. I'm going to tell you where it came from. This is not code that I wrote, guys. This is going to be code that I am using from somebody else. So I'll talk about that in a minute. But let's go ahead and add the class. And I'm going to... It's a C++ class. Yes. So we're going to call it hash class. Leave everything else alone and drop it in. This is not going to be part of memory management. This isn't really a container. This is actually kind of just a utility. So what is this? The hash class, the purpose of a hash class, and I know we've kind of a little bit talked about this already, but it's to take a string of any size and convert it into a, well, we're going to convert it into an unsigned integer. Okay. The idea is, if you send a string, what you want back is the unsigned integer, which is deterministic, which is to say, if I send a string to that function, it'll always return the same unsigned integer as long as that string is identical. So no matter how many times I send, wherever it was, WinBase, I think it was under, if I send new pool in, it should return a particular unsigned integer every single time. No matter how many times I send this in, it can't change. However, if I change this by even a little bit, like say, even just change it by a single letter, like change this L to M, new poom, that should result in a completely different unsigned integer. I mean, a radically different one, nothing that's even close, hopefully. And that's the idea. It is also useful if your hashing function can assure uniqueness. Now, hashing functions generally don't, and this one doesn't. However, I believe I read, if I'm not mistaken, that this one has a collision probability in the millions somewhere. So we still have to worry about it. It's still something we need to check for if there's a collision between two different strings, but the chances of that are pretty slim. But it's not something we can ignore, because, you know, computers are good at repetition. So if you're doing something a million times and you have a 1 in a million chance of the string colliding with something, then there's a good chance it's going to collide at some point, right? Yeah, you know, so it is something we have to deal with, the potential for collisions, but hopefully it's not something that comes up too frequently that we have to worry about too much. So yeah. All right. So let's talk about this hash class. Okay. So basically, other than the constructor and the destructor, there's really only going to be one function. Unsigned int hash. Then we're going to get a constant void star key. That's going to be the string of byte length. And I'm not going to make the byte constant, because we're gonna change it in the course of the function. And then constant unsigned int modifier, and we're going to give this a default of 0. Okay, so we aren't going to use the modifier. Let's go ahead and put in here. Whoops, that's the wrong. Jeez, come on now. Include engine base. And that should take care of the byte. Yep, there you go. All right, there you go. Okay. Just going to get out my little delimiter, my little separator, I suppose is a better word. We're actually not even going to use the constructor and destructor, to be honest. There's not going to be anything in them. So really, that's your only public function right there, this one right here. Now I should put in the copy constructor and the assignment operators and all that kind of stuff. I really should. I'll do that later. I say that, but I really should. I'll do it later. I'll get to it, I promise. So let me put in this code. And this is complicated, guys. And I'm really not going to explain it very much. So I'm just copying and pasting this from my Scratch code. Okay. So first of all, like I said, I didn't write this code. This is not my code. So if you go to this link right here, this BurtleNet BBC C lookup 3, if I pop that open, oh, I didn't know it would open there. Okay, never mind. Let me just grab the address and we'll pop it open in our browser. It's easier to read that way. Okay, here it is. So this is called lookup3.c by Bob Jenkins, which he wrote in 2006, and he put it in the public domain, which is one of the reasons why we can use it here. Well, it is the primary reason we can use it here. These are functions for producing 32-bit hashes for hash table lookup. Hash word, hash low, hash, etc. are externally useful functions. Routines to hash specifically. Yeah, I don't see where he talks about collisions in here. It must have been on another part of the page. So anyway, there's a self-test there. That's not really that important to us. I don't know if he talks about collisions in here, but he does talk about kind of some of the functionality of this. So yeah, I mean, go ahead and read through this if you're interested. There's a lot of funky math in here, but basically, guys, what it comes down to is it's a function for converting a string into an integer, like I said before. Okay, and I'm not going to go through like the math for this. There's a bunch of math, and I could explain it, but explaining the math really doesn't tell you why we're doing what we're doing. It doesn't really. I mean, I can tell you what it's. Yeah, we're adding in these K0, K1, K2, which are defined somewhere up in here. Actually, I'm not sure where. Where is that defined? Go to the definition. Ah, there it is. Oh, it's just part of the key. That's what it is. Okay. So it's taking the first three letters of the other thing. It's doing a mix on them, subtracting off some length. It's I can tell you bit by bit what each piece of math is doing, but that doesn't really tell you what it's really doing, right? And I'm not going to try to explain it. Really, to be honest, I don't fully understand it myself. It doesn't matter. The point is that this is a hash function which takes a string and gives you back an unsigned integer. That's what it does. Okay, there's a couple of private functions that we don't have yet. We have mix down in here, and there's one other that should be final. So let's grab those as well. I deliberately didn't grab those the first time. There's a third one called rotate, actually, also, which is probably somewhere up in here. I think it's towards the front. Well, maybe not. Oh, you know what? Rotate might be inside mix and final. Now that yeah, there it is. It's rotate. So yeah, there you go. Those are all the functions that we need. And I will put those in. Let me just grab it from my scrap code. As private functions. So there you go. That's how that looks. So there's really only one public function, hash. Now what's great about this is it doesn't use dynamic memory, so we don't have to worry about the fact that we don't have dynamic memory. It doesn't use pointers. Well, I mean, it does use pointers, but it doesn't need any kind of special smart pointers. Like, let's see, there's a pointer right here. But that's part of a union, right? It's actually being defined as an unsigned integer. Okay, so yeah, you pass it a string and it gives you back an unsigned integer. That's its function. So there you go. That should compile. Let's just make sure. Let's make sure I didn't forget anything. Very good. Now that we have that, we originally had a constant character name which we passed into the memory pool class constructor. So let's deal with that here. There it is. Okay, so we put in this to do hash the name string and store it as the pool ID. So this is simple enough. We'll just say name hash equals. We're going to access it through the global manager, get hash. Dot hash, and then the name, the size of the name, and that's it. You don't want to put in a modifier at this point. Okay, so the name hash is going to be an unsigned int. So memory pool, where's my memory pool class? So we'll say unsigned. Gosh, I can't spell. Unsigned int name hash. There you go. That should take care of that. That should make that happy. So, okay, let's take a look at Global Manager real quick. All right, let's put here. We'll put let's see, hash class global manager hash class. So there's the so there's the actual declaration of the class. We're gonna have to put in here include quote hash class like such. Static hash class hash. Okay, static hash class get hash. I think that's what I called it, right? And then of course in global manager CPP, we're gonna have to define this function down here. Why don't you like that? Should be that. Okay. Hash class, do this. Hey, hello. Grab that, stick that there, make that part of the class, and put in our little thing, and then we're going to return hash. There you go, like such. Yeah, what have I done here? Remember what I was saying about how I was doing stupid things? I don't like this. I'm not even sure that's going to work. I'm going to change this to a pointer to the class instead of the actual class itself, so we're not copying classes over. Like such. And then, of course, I have to change this. Okay, so we need to return a reference to the class, reference to the class, reference to the class. Then we need these to be pointers. Pointer, pointer, pointer. That makes me happier. Instead of returning an entire class, we're returning a pointer to that class. That's better. I don't know why I did it that way. Sorry guys, of course this is going to cause problems. What did I do here? I didn't put in a semicolon. That's one problem. Let's fix that. Global manager. Yes. Include quote global manager dot h. Get hash. So let's see, that's going to have to change to that. There, that's better. Okay, let's see what else we're getting. We're going to have to fix these things because I changed them. Okay, it's done. Don't mess with stuff. Because I changed them to pointers instead of copies of classes. So let's do that. That's better. I like that better. Let's see, that should almost run, I think. Yeah. Okay, how are we doing here? Probably memory leaking. Okay, very good. Yeah, very good. I like that better. All right. So we have this done. Let's see, where's my task list? Why does this do that? That's the malloc error. So there's only one thing left on the task list, and that's the malloc error, and then, which we'll do something about later. I can't do anything about it right now. Okay, so we've got the name hash stored as part of the memory pool class. So when we get the pool ID, instead of returning 0, we should return the name hash, like such. Okay, looks pretty good. I think that's pretty good. Okay, we're on the verge of having a working memory management system. Minus the memory pools. But. Okay, so we shouldn't need hash class anymore. That should just work. We should really never have to look at it again, which is good because I don't like classes that I didn't write, even though it's a perfectly good routine. Okay, yes, we're gonna have to modify this a little bit, I think. Right. I think what I want to do is when we add new pool, we want to return the that hash when we do the pool, right? Because that makes sense. Because we need to keep that when we create pools. So, in order to do that, what we're going to say, let's see here. So we got the pool. Let's create unsigned int pool ID. So we'll say well, do we need to actually create? Maybe we don't need to create a whole. Return get pool ID. I don't think we actually need to create a whole new thing. We just need to return the pool ID. If align pool pointer equals null pointer, this is the error. Let's just return 0 here. Looks pretty good. Looks pretty good. Yeah. All right. Okay. The other thing we have to do, we've got this first pool that we need to deal with, and remember that in the constructor we set that to null pointer. So let's do that. Let's deal with that. If first pool equals null pointer, that means this is the first pool. First pool equals new pool. There you go. Just that easy. I don't need to worry about last pool right now. I'm gonna leave that alone for the moment. We just need to know where the first pool is. And I'm not gonna worry either right now about the whole linked list thing. In the memory pool class, did we set this up? We didn't even set this up yet. So let's get it working for one pool first, then we'll worry about getting it working for multiple pools. But for right now, let's just worry about the first pool. Okay, let's talk about the delete pool function. What do I need to add to this? Do I need to add anything to this? Memory dying pool equals first pool. free memory, return, dying pool. No, I think this will work. I don't think we need to change anything here, so we're good there. Yeah, I think so. Okay. All right, now, it all looks good, I think. Okay, let's go back to WinBase for a minute here. So, up top here, let's put in our this is where we'll keep this right here for right now. I mean, this is completely temporary, of course. Most things in here are, right? So we're going to say, remember we returned the memory pool ID from add new pool. So we're going to keep that. And then we're going to go through the message pump. And then before the program ends, what we're going to say is, how do we want to do this? So we got to go through the global manager, get memory manager. Let's see, did I already do a delete pool? I did. Cool. Okay. And then you got to give it the ID of the pool, which we kept. It's memory pool. Oh, too many L's or too many O's. That should delete the pool. Okay. All right. Is that going to work? Let's find out. Let's see if it compiles. It seems to compile. And it didn't crash on me. That's promising. Okay. Run that again. Let's see here. Can we tell? What am I? Probably not. Tell you what. Let's. I want to see that actually at work, just to make sure it's actually destroying that memory. So under the memory manager class, when we delete that pool, I'm going to right here. That's the function. I'm going to start right here. I'm going to put a break in right here. Let's run that. So I want to make sure this is working. Okay, so we go up to 1 megabyte. We stop. Okay, let's go ahead and step through this. Memory start gives us this big little number. We should be deleting the pool. That's not going to change anything. Free the memory. Yeah, unfortunately I'm not... okay, I'm not killing enough memory to really be able to see it. How much are we doing there? We're doing 1 kilobyte. So if I want to do a megabyte, that's 1,000. Say if I want to do 5,000. Let's see what that looks like. Let's see if that's noticeable. Okay, we're up at 7 megabytes, so I'm going to close it. And we'll step through that. Dying pool, free memory. Still really not seeing it. Maybe. Because we're out here now. Okay. I'm still not entirely convinced. I'm going to put something ridiculous, like, I don't know. What should I put? 500,000 kilobytes. So that's going to be about 500 megabytes. Is that right? Let's find out. Yeah, so 539 megabytes is currently being allocated to this program. Let's stop it. Let's step through that code. Memory usage. No, I can't. Okay, we're out here now. Okay. It's not helping me. It seems like it's working though. I feel pretty good about it because it's clearly up at 500 megabytes, right? 539 megabytes. Actually, 490.3. If I close this and then I step through the code, unfortunately it disappears. Ah, there we go. That's what I wanted to see. Okay, it's good. So here we're at 490.3 megabytes. Here we're at, let's see if I can get it to register. Something really low. 1.1 megabytes, which is just the program itself. Okay, good. That worked. It's working. It is in fact deleting the memory. We're not memory leaking. So we're good. Looks pretty good to me. Okay, guys. How are we doing on time here? Well, I've rambled on for quite a bit. I feel like we're in pretty good shape. Yeah, we're pretty good. Obviously, we don't have the new functions are not working yet. You can't actually use any of this memory, but we have it set aside. And we've got a single pool working. We're not that far off from getting multiple pools working. Really, it's just a matter of bookkeeping on that one. But we can create the memory, we can delete the memory, so we're in actually very nice shape. I'm going to put this back down to something reasonable before I forget. We'll do 5 kilobytes for right now. So yeah, and let me check the global memory class just one more time real quick. Make sure I'm happy with this. That's much better than it was. Yeah, if you guys see me do something stupid, feel free to tell me about it. There's a good chance I will have seen it already when I was doing the editing. But like I said, it's hard to do intelligent code while you're trying to explain it. You're not really concentrating on the code. I'm concentrating on trying to explain my code, and it doesn't always come out great. A lot of times I have it pre-coded, but sometimes I just wing it, and I probably shouldn't do that. But to me, it's always, well, sometimes it's just easier for me to wing stuff than it is to pre-do it. But I think that should work fine. I think we're good. What's in memory pool class right now? Or sorry, memory block class. This is empty. Yeah, we're going to be working on that soon. But I mean, really, the super hard stuff is done. There you go. I mean, and I think it's working fine. Okay, guys, I've rambled on a long time. I know this was a little bit of a rambly episode, and a lot of that is because of hash class, which again isn't my code, and it does a lot of funky math, but it's really not important to understand this math. You really need to really understand the purpose of the function more than the actual mechanics of what's going on here. It's not important. It really isn't. I mean, you can go through and figure it out if you want to. People who are into hashing, who are much smarter people than I am, have all figured this out for us, and we don't need to worry about it. We just know it works. I've used this code several times before in the past, so I know it works fine. But if you want to commit yourself, feel free to run through it and check out what it does. So yeah, take a look at it if you want to. So anyway, okay, we will stop here and we will pick this back up in the next video. So I will see you guys in the next one. Thanks a lot.